These are based on whatever we have learned till now in Haloalkane, Haloarene. Also, Fatima, you are free to look into the note. Okay, you can, if you find the same reaction, try to think about it, why it is happening, and then again write the answer. Okay, so you'll find most of these problems in the notebook itself. तो मरियम वाफिया, आप लोग बस आके ऐसे बैठ जाते, कोई सलाम कोई कलाम कुछ नहीं। यस मरियम वाफिया। Oh, I'm not audible or what?
You
Yes,
are
guys,
audible. Yes, sir.
I am audible, right? Okay. Uh, Fatima, I think the first one is fine. The second one you did not do. Third one is fine. फोर्थ वन में एक ऑब्वियस प्रॉब्लम है जो आपको दिखना चाहिए। बताइए सबसे पहला प्रॉब्लम क्या दिख रहा है आपको फोर्थ वाले में? Fourth and fifth one obvious problem that you can see. Good evening, Mariam. Fatima, can you see something in the fourth one?
There is 2OH.
No, yeah, fine. But again, like look at the ring and tell me, do you find something missing?
Benzene.
Correct. One thing is that for sure. Okay, one thing is that. And then see this fragment here, the blue one that I have written. This is not alcohol, na? Is this alcohol or is this phenol?
It's phenol. Yeah.
Right? It is not alcohol. But if you look at this fragment here, CH3OH, this is alcohol. So, and obviously we have also written that SOCl2 and the other methods from, we will prepare haloalkane from alcohols and not from phenols, right? So the product will be, see, this blue part will be as it is, nothing will happen to the blue part. Okay, but you will form a chlorine here like this. Now, if you look at this one here, so यहाँ पे तो peroxide नहीं है ना, so you have to attach this. I don't know why you, because we don't have any peroxide, right? Yes or no, Fatima?
Yes, sir.
Okay. For the first one, it is going to be, you have done it rightly. And this Br2, if you remember, it is going to give you a product like this, Br here. If you want to draw only one product, that is going to be your major product, okay? Because this 2-degree free radical is going to be more stable. It is free radical halogenation. Third one also, you have done it rightly. You have added a Br in this carbon atom, that is correct, okay? And you have also made it very correctly like this. The structure should look like this. Okay, so guys who are coming late, please try to come on time. I revise the previous class and then I move on to the next class, right? So please write these answers. So by the way, why you would write this answer? You will try this after the class. Okay, now in the last lecture, we saw that if we have alkenes and we react with HBr, then in the presence of peroxide, it is giving me some different product. In the presence of peroxide, it is giving me, the Br is attaching on that carbon atom which is having more number of hydrogen, and in the absence of peroxide, it is giving me this product, right? This is giving me 2-bromopropane, and in the presence of peroxide, it is giving me 1-bromopropane. Why is this happening? We'll look at that and then we'll move on to the next topic. Okay. Actually, first of all, we'll see what is known as the Markovnikov's rule. What is known as the Markovnikov's rule? So please write first of all Markovnikov's rule. Or you can write Markovnikov's addition, or it is also known as Markovnikov's rule. Okay. Please write here. When unsymmetrical alkene is treated with unsymmetrical ether, sorry, unsymmetrical alkene is treated with unsymmetrical reagent, not ether, sorry, my bad. unsymmetrical reagent. Then the negative part of the reagent attaches to that doubly bonded carbon which has lesser number of hydrogen. Okay. So why is this happening? We'll write a mechanism. Okay. In mechanism, we'll look at this particular alkene. When I treat this with, let us say, HBr or HCl or HI, it is going to give me a product like this. So why is this happening? Write the first point. Now, in the first step, what is going to happen? In the first step, this alkene, it will react with HBr. If you look at HBr, whenever you look at a reagent, you should identify the electrophilic side and the nucleophilic side. So this is delta positive and this is delta negative. So obviously hydrogen is going to be delta positive, right? Because Br is electronegative, it is going to pull the electrons from hydrogen atom, making it electron deficient. If I look at alkene, this double bond here, it has a pi density, it has an electron density, higher electron density. So a reaction will happen something like this, from electron source to electron sink, and this Br will leave. It will give me, now, if you look at this particular thing, then there can be two products. This alkene, it has two carbon atoms, right? This green carbon atom, and then we have this blue carbon atom. Let us suppose that the hydrogen gets bonded to the blue carbon atom. So I will get 1, 2, 3 carbon atom, the pi bond is broken, and the electron from pi bond has been used to form a bond with hydrogen. And since the second carbon atom, it is not having any particular hydrogen and it has lost a bond, it will get a positive charge. It will get a positive charge. Okay, why it is getting a positive charge? See, this blue carbon, it had 2 bond. Now also this blue carbon is having 1 and 2 bond. This green carbon was initially having 2 bond. Now it is having only 1 bond. That means it has lost electron. That means we will get a positive charge. Now let us suppose that this pi bond breaks and the carbon from the green, it gets attached. It attaches the hydrogen atom to itself. So we'll have something like this. And from here we can say that the positive charge will be generated in this carbon atom that is on the end. Okay, because as you can see, we have got 3 bonds. This green carbon had 3 bonds, 1 bond from here, 2 bond and 3 bond. And right now in the product form, when it has attached hydrogen, it also has 3 bond. But this blue carbon, it is not having those 3 bond, it is having only 1 bond. And here it had 2 bonds. So it is getting a positive charge. Now, if you see this particular,
understand how the positive charge is going where.
ठीक है, चलिए एक बार बताइए, हाइड्रोजन समझ में आ रहा है?
Yeah.
ठीक है. अब पहले आप देखिए ब्लू वाले कार्बन को. ब्लू वाला कार्बन यहाँ पे जो था, this carbon was making how many bonds? Here. It was making how many bonds?
2 bonds.
2 bonds. And here it is making how many bonds?
2 bonds.
2 bonds. That means कोई तो number of electrons में फर्क नहीं आया है इसके, right? It was already. Look at the green carbon, how many bonds it is making here?
3 bonds.
Here it is making how many bonds?
2 bonds.
That means it has lost 1 electron.
Yeah.
That means it is getting positive. अच्छा, ऐसे आप बोलेगा सर बॉन्ड खोया है उसने तो 2 इलेक्ट्रॉन गए होंगे ना, लेकिन 2 इलेक्ट्रॉन में याद रखिएगा कि 2 इलेक्ट्रॉन में 1 इलेक्ट्रॉन तो इसका था, ग्रीन का एक ही इलेक्ट्रॉन था, जो अगला इलेक्ट्रॉन था वो ब्लू वाले कार्बन का था, राइट? द ब्लू कार्बन हैड शेयरिंग ऑफ इलेक्ट्रॉन से बनता है बॉन्ड, राइट? सो दैट इज व्हाई वी विल से दैट इट हैज लॉस्ट ओनली 1 particular electron. It has lost 1 bond and 1 electron of its own. That is why we are giving a positive charge. Now you understood this? Yes or no? Tell me.
Yes, sir.
Okay. Now you will tell me this is 2-degree carbocation. Yes or no? And this is 1-degree carbocation. I hope all of you can identify this now. 1 degree and 2 degree. Yes or no? Please tell me. Can you identify this as 1 degree and 2 degree? Fatima, Wafia, what happened? Razan? No. Yes or no में हमको जवाब दीजिए, जल्दी जवाब दीजिए, ठीक है ना? आप लोग हमेशा इतना ही टाइम लगा देते हैं हर चीज को जब हम पूछते हैं. डू यू रिमेंबर 1 degree 2 degree कार्बोकेटाइन? Yes or no? Fatima, tell me yes or no. ठीक है. I'm just assuming that you guys know this. Now, since 2 degree carbocation is more stable, the further reaction will happen from the 2 degree carbocation, because if it is more stable, this will be forming more and more often, and we will be not getting this particular carbocation. This will be forming more often. And if it is forming more often, then I will take this carbocation with a positive charge. We don't show hydrogen. I have shown hydrogen here just because it is getting added. Right now, I will not show any hydrogen. Plus, we have the Br negative that is dissociating from here. And this Br negative is going to attack onto this carbon atom, and it is going to form the major product, that is a Br in the second carbon atom. Okay, so please write this down. Let me know when you're done. Okay, also one more thing. This is less stable, but you will also have this product. ठीक है, ये भी बनता है, but it is minor. This is major. This is minor product. Major product means formed in larger amount. Minor product means formed in lesser amount. Done, guys? Yes or no? Please tell me. Okay. Mariam, where did you go to play?
Sir, our matches haven't started yet.
Actually, it has not started yet. Which game, by the way? Which sports or game?
Basketball and
Basketball.
badminton, I got selected.
Oh, badminton also. Okay. You
Yeah.
watch badminton? Or you just play badminton?
No, sir. I don't have time for what.
Not now. Not. अभी नहीं. अच्छा अच्छा, आपके पास अभी time नहीं.
No, earlier also I've never.
Never. Okay, fine. Done, all of you? Okay. Now write next the anti-Markovnikov's rule, or it is also known as Kharash effect or the peroxide effect. Please write. Anti-Markovnikov rule. It is also known as Kharash effect. This is also known as peroxide effect. Right here. When HBr is treated with, this is only for HBr, okay? When HBr is treated with unsymmetrical alkene, in the presence of light or peroxide, then the Br attacks Either you write attaches to, that a doubly bonded carbon atom carbon which has higher number of hydrogen. Okay, so in this also we'll write a mechanism. If we have an alkene like this, in the presence of H nu, that means light or peroxide. And in this case, the Br is going to attach on this carbon atom that is having more number of hydrogens. So we'll talk about the mechanism of this reaction, why it is happening like this. See, the first step is here. What is happening? The first step, the HBr gets associated in the presence of peroxide or H nu, and it forms radicals. So I will get H free radical and I will get Br free radical. Okay. Now, when we have H free radical and Br free radical, then what is going to happen? In the presence of H free radical and Br free radical, we'll next have alkene. In alkene, we have CH3, single bond CH, double bond CH2. Okay, double bond CH2. Now again here also, this particular hydrogen, it will going to get attached, right? Okay, guys, tell me here, which is more reactive, the H free radical or the Br free radical will be more reactive, which is going to attack on the alkene. Make a guess and tell me. Okay, Br. Okay, see, if we have peroxide in here in this case, now the peroxide has this type of bond. Wait a second. Peroxide is like this. R. Wait a second. एक काम करते हैं, peroxide से start करते हैं. The first step, if I will write peroxide. Okay, so it can be any alkyl peroxide or phenyl peroxide, benzyl peroxide, any type of peroxide. That means we'll have OO bond, and this OO bond, it cleaves like this. We get R O free radical plus we get R O free radical. In the second step, this RO free radical, it reacts with hydrogen and Br. Now here what happens? The oxygen free radical come up with its own 1 electron. The hydrogen come with its 1 electron, and they form alcohol. And then we are remaining with Br free radical. Okay, so this one Br free radical is remaining. Now in third step, what is going to happen? We have CH3 bonded to CH and double bond with CH2. Now we have only Br free radical. Now this Br free radical, it can get attached. Now it is going to attack by this double bond carbon atoms, and we have two carbon atoms here also, the green carbon, and then we have the blue carbon. So if I'm going to attach the Br in the blue carbon atom, then I will get CH3. Wait a second. Okay, so I'll get CH3, CH, single bond, because this double bond has been broken, CH2 and Br. Now, since you can see that this double bond, it is using only one of its electron, as you can see from this particular arrow. It is fishhook arrow with a single headed arrow, right? So we'll have one electron left in this carbon atom. Okay, so this is one of my product that we can form. And the another product which can be formed, if we add the Br in the second carbon atom, we will be getting CH3, CH, Br here, and this now CH2 is going to get a free radical. Now, if I look at the free radical, this is 2-degree free radical, and this is 1-degree free radical. So free radical is just like carbocation. The 2-degree is more stable, and that is why this will be more stable. And the further reaction is going to happen from this particular free radical more often. So you have CH3, CH, CH2, Br, 1, 2, 3 carbon atoms, and then a Br with a free radical. Plus, what will happen? Then we will have some more HBr. So this free radical will attack onto hydrogen. Hydrogen will come up with its own 1 electron, and it is going to form Br here, and the hydrogen will get attached onto this carbon atom. So this is going to be your major product. And from the 1-degree free radical, this is going to form your minor product. I write the steps down. Please let me know when you are done, guys. Okay, so this was, wait a second, just now. From alcohols, A part was addition, like B part from alcohols. No, from alkenes, B part. Halogenation of alkene. Okay. Halogenation of alkene. Now in halogenation of alkene, we are going to add here just halogen atom, such as Br2, and then we have Cl2, I2, F2. These type of halogen atom, if we add onto alkene, it will show an addition reaction. That means the double bond will be broken, and both the carbon of double bond, it will get a halogen atom like this. Okay, so please write. Please write with me here. When alkenes are treated with halogens, they form vicinal dihalides. What is the meaning of vicinal dihalide? Carbon with double bonds plus, if we have, let us say, for example, X2 in general, Then both the carbon atoms, what is happening here, guys? Then both the carbon atoms are going to get X, X. These bonds are going to be as it is. So what is happening? CC pi bond breaks, and this C forms a bond with halogen atom, and this C forms a bond with halogen atom. These are the bonds which are formed. Okay, so this is vicinal dihalide. Okay, you can write a note also. Alkyl halides with halogen atom on adjacent carbon. Carbons are called vicinal dihalide. Vicinal dihalide comes from the word vicinity. Vicinity means similarly, right? Vicinity means neighborhood, right? When they are in adjacent carbon atoms. Right here, next point. Bromination of alkenes is also used as a test for multiple bonds. Okay, so if I have alkene plus Br2, this Br2 is reddish brown in color. Okay, it is reddish brown in color, and when you will mix it, you are going to get vicinal dibromide, vicinal dibromide, and it is colorless. So what does it mean? It means that if you have if this is a sample will turn this reddish brown Br2 to colorless if it is alkene. Okay, if it is alkene, then it is going to convert it to colorless. You can write some examples here. Double bond like this plus Br2, it is going to give you Br in this carbon atom and Br in this carbon atom. Furthermore, let us suppose if you have something like this. Here also, let us suppose you have Cl2, chlorine here and chlorine here. Write down the product for these two. And Sindhi, please see that I have broken the pi bond. ठीक है, आप लोग ना बिल्कुल ये ध्यान नहीं देते हैं. ध्यान से लिखिए इन सबको. इसमें देखिए like what are the bonds being broken and what are the bonds being formed, and then send the answer for 3 and 4 to me. I want answer from everyone. Okay, Fatima, Mariam, Razan, and Wafia. Yes, Razan, correct. Waiting for Fatima, Wafia, and Mariam. Yes, Wafia, correct. Fatima, yes, correct. Okay, since all of you have done this, I think Mariam got disconnected. We can move to the next topic. Okay, so till now we have seen a few methods for the preparation of haloalkane. And those methods are, first of all, we saw from alkene, free radical halogenation of alkene. Then we saw from alkene. Okay, then we also saw from alkene. By the way, write one question. Quite interesting question. Give it a second. A hydrocarbon C5 ester does not react with chlorine and dark. Okay, C5 ester, a hydrocarbon. That means this hydrocarbon. If it is hydrocarbon, that means it can be alkane or alkene. Only two things. There cannot be anything other if it is hydrocarbon. And the formula is C5H10. It is saying does not react with chlorine. It does not react with, if I react this with chlorine, Cl2, in dark, it is not going to show any reaction. This will give me no reaction. Correct? This will give me no reaction. Now, if you see here, this type of reaction, if I have any alkene and I react this with any halogen and I am not giving any light, it is reacting. Yes or no, guys? Please tell me.
Yes, sir.
It does react, right? That means if this particular C5H10 is not giving any reaction in dark, that means C5H10, can it be alkene or it will not be alkene? अगर ये alkene होता तो product देता, correct? Yes or no? Right?
Yeah.
Now C5H10 is not alkene. Now, but if you look at this formula, C5H10, it is in the form of CnH2n. Now you may remember from like lower standards that CnH2n is for alkene. True, but it is also true for cycloalkenes. Cycloalkenes also have same formula, CnH2n. That means what is the next statement? But gives single monochloro compound in bright sunlight. Okay, so this is also very much. So if we have C5 Western in cyclic structure, it will look something like this. All of these carbons are having 2 hydrogens, right? I hope you can see, because they have 2 bonds with carbon, the other 2 bonds will be fulfilled by hydrogens. Yes or no? And from here you can see that all of these carbons are also same. Yes or no, guys? Please tell me. All these carbons are same, correct? Yes or no? What happened? Can you not see that? Okay, what happened? Wafia and Razan, आप लोग को नहीं समझ में आ रहा है? What I'm asking? Yes, Razan, tell me. Razan, what happened? Razan, Wafia.
Yes, sir.
Why are you guys not answering? Okay, Razan, your voice is not coming correctly. Wafia, at least you answer. Okay, if your connection is fine. Okay. Can you see that all of these carbon atoms are same? Yes or no, Wafia?
Yes, sir.
Right. So it is going to give me a product in which any one of the carbon atoms will get chlorine. अभी आपको याद होगा. If I mean you will remember this only when you have revised the last class. Okay. So that means this C5 Western. This is my C5 Western. And that's something that they have asked. Identify the hydrocarbon. Okay. This is my hydrocarbon C5 Western. That is cyclo. Pentane. Write this down.
Sir, can you show the question once?
Done everyone, is please tell me.
Yes.
Okay. Before starting going to the method of preparation of halorene, you write the next method. One more method is there. This one is known as by halogen exchange. Okay. Now in halogen exchange method, we have 2 different methods. Okay. One is known as Finkelstein method, right? Number 1. Finkelstein method. In Finkelstein method, you write this involves reaction of reaction of chloro or bromoalkane with sodium iodide and dry acetone to form iodoalkane. Okay, so if we have Rx and you react here sodium iodide in the presence of dry acetone. Dry acetone means Acetone is liquid, okay? It does not mean that it is not liquid. Acetone is liquid. Dry acetone means acetone in the absence of water. There should be no water. Why there should be no water? Because we have sodium, right? And sodium and water, they will, I mean, they burst out if you add sodium into water. Okay, so Rx in sodium iodide, it is going to give me Ri, alkyl iodide, plus NaX. Some examples you can write. You have Br, and this X can be chlorine and Br only, okay? Dry acetone, I'm writing it in short form. Dry acetone. This is going to give you iodoethane plus NaBr. Can write one for chlorine, sodium iodide, dry acetone. The chlorine will be replaced by iodine, NaCl. Tell me if you're done, guys.
Done, sir.
Right, next B part. Schwarz reaction. Please write here in Schwarz reaction. When chloro or bromo alkane is treated with metal fluorides, they form fluoroalkane. They will form fluoroalkane. So if you have any Rx, where X is equal to chlorine or bromine, and you react here with any metal fluoride, okay? I'm going to write what is going to be the metal fluorides also. If you react any metal fluorides, then it is going to give you fluoroalkane plus, what will we get here? We will get any MX, okay? What can be the metal fluoride? The most common metal fluorides are AgF, silver fluoride, Hg2F2, and SbF3. Okay, I'll write one example from all of them. If you have Hg2F2, it is going to give you, it will replace the chlorine and you will form Hg2Cl2. We have SbF3. If you have SbF3, it is going to give you the bromine will also get replaced by fluorine, plus you will get Sp Br3. Done everyone? Yes or no? Please tell me, guys.
Yes, sir.
Okay. Right, next. This was halogen exchange method, third, and right method of preparation of haloarene. Now, in haloarenes, you will first of all write A part, halogenation of benzene. Okay, right. When benzene is treated with chlorine or bromine, in the presence of a halogen carrier such as FeX3 or AlCl3, FeX3 or AlCl3, then it forms haloarene via electrophilic aromatic substitution reaction. So you will start with benzene. Plus Br2 in the presence of FeBr3. Then it is going to give you Br plus you will get HBr. Similarly, you can also have benzene derivative. For example, if you have toluene, this is methyl benzene, but it is commonly known as toluene and famously also known as toluene. If you have Cl2, then we are going to use something like AlCl3. Now this toluene, it is ortho and para directing, and that is why it is going to give you two products. CS3 with a Br here, this is going to be major. Plus CS3 and Br in the ortho, this is going to be minor. Razan, do you remember this from 11th standard? Yes or no? Tell me. कुछ याद है ये सब? Electrophilic aromatic substitutions? नहीं. Yes, Razan. You can answer in chat. नहीं याद. Okay. You can answer in chat. Do you remember this or no? You can also use the same reaction if you have, let us say, for example, Cl, and you want to have dichlorobenzene. Then you will react with Cl2 in the presence of again AlCl3. Now this chlorine is also ortho and para directing. Fatima, do you know this? What is this ortho and para directing? Yes or no? Tell me.
Yes, sir.
Okay. I shared with you guys the 11th standard lectures. The 11th class lecture हमने शेयर किया क्या आप लोगों से?
Yes, sir.
आपने देखा उसमें से?
नहीं, sir.
अच्छा नहीं देखा, लेकिन ठीक है, पता है फिर भी आपको ना. Okay.
I know what's one time.
But can you identify whether it is going to be ortho para? जैसे for example अगर हम नाइट्रो ग्रुप यहाँ पे लिखते हैं. And I am doing Br2. Then what do you think? What is going to happen? ऑर्थो ग्रुप ऑर्थो है या पैरा डायरेक्टिंग है? ऑर्थो पैरा डायरेक्टिंग है या फिर इट इज मेटा डायरेक्टिंग? किधर जाएगा? ठीक है, जैसे अब ये NO2 जो है वो आपका मेटा डायरेक्टिंग है. So how to identify all of these things? Please watch the mesomeric effect lecture, okay, from wherever I have shared with you. Okay, write a note here. We can say fluoroarene or fluoroarene cannot be prepared by this method as the reaction with fluorine is very violent. It's very fast and it is very violent. Reaction with iodine is reversible and hence done in the presence of a mild oxidizing agent, in the presence of a and लिख लीजिए oxidizing agent. Such as HiO3 or HNO3, etc. You can write the reaction with benzene plus I2. Now it will happen in the presence of what? It will happen in the presence of, let us say, HiO3. Then it is going to give you iodobenzene. After this, you will write the Sandmeier's reaction. Let me know when you are done, guys. Okay. Right here, Sandmeier's reaction. B part. Assalamu alaikum, Aisha. How are you? Aisha, am I audible? No. Okay. Right. Sandmeyer reaction. When benzene diazonium salt, when benzene diazonium chloride लिख लीजिए आप लोग, and benzene diazonium chloride is treated with cuprous chloride, or bromide. It leads to the formation of chloro or bromobenzene. Chloro or bromobenzene. Okay. Right. Next point. Benzene diazonium salt, benzene diazonium chloride. Write in short as BDC. Okay. Benzene diazonium chloride can be prepared by treating aniline with nitrous acid and HCl and hydrochloric acid. Okay. So actually दोनों के इस्तेमाल करने की जरूरत पड़ती नहीं. Like nitrous acid, it cannot be prepared in the absence of HCl. So first of all, what we do, we have NaNO2 and we treat this with HCl. And what do we get? We get here ONO. क्या मिलता है इससे हमको? ONO, that is nitrous acid. Okay, ONO. Now, when we treat this ONO, now again, this ONO is also prepared in C2 only. Okay, so I will start with aniline with benzene ring with NH2. This is my aniline. And then I will add here these two things, NaNO2 and HCl. Okay, we cannot have nitrous acid. Now, if we will have nitrous acid, it dissociates. Okay, it dissociates in the room temperature. So we'll have NaNO2 plus HCl. This will be formed from 0 to 5 degrees Celsius. Okay. So when we do this particular reaction, we have an ice bath, and in that ice bath, we are going to put this thing. Now, when we treat this, we are going to get BDC, that is benzene diazonium chloride. Benzene diazonium chloride is something like this. Get here N2 positive, and then Cl negative will be there. And that is why it is also known as benzene diazonium chloride or benzene diazonium salt, BDC. And then we just react this with cuprous chloride or bromide. We have this benzene diazonium chloride, and if you react here with Cu2Cl2, then it is going to give you chlorobenzene. And if you have a same benzene diazonium chloride, into Cl, and you are reacting this with cuprous bromide, that means Cu2Br2, then you are going to get bromo benzene. Write the C part. BDC plus Ki. Okay. So write to prepare iodoarene. To prepare, rather write iodobenzene. Benzene disonium chloride is warmed with. It is warmed with aqueous Ki. We have a simple reaction. N2 plus Cl negative plus Ki aqueous. We will warm it. And you are going to get iodine here. That's it. Okay, one more thing. Please write this on Wednesday. You will have a 10-mark test on IUPAC and method of preparation of haloalkane and haloarene. Okay, whatever we have done till. Write this down. Let me know when you're done. सबने लिख लिया? Fatima is done. What about others? Done? Razan, Wafia?
Yes, sir.
Now, let us write a few points regarding physical properties now. Okay. By the way, see, whatever we have done till now, I'm going to write here. We have prepared. We have looked at the method of preparation of haloalkane. Haloalkane can be prepared from alcohols. Just use several methods. It can be prepared from alkane. In alkane, we have only one method. Then we have alkene. In alkene, we have two methods, right? You remember it in this way. So we have done only these three things when we were doing. Okay, one more method is there: halogen exchange. Okay, you try to make a like mind map like this. Okay, haloalkane can be prepared from these things. Then we had haloarene. Now haloarene can be prepared from electrophilic aromatic substitution reactions from benzene. Then we had Sandmeyer reaction. And after that we had BDC plus Ki. Please remember this BDC plus Ki, it is not Sandmeyer reaction. Okay, it is not a Sandmeyer reaction, not an example of Sandmeyer reaction. Fine. So remember it in this way and also try to prepare a mind map for this. Okay, try to prepare a mind map for this. Okay. Right, next point, that is physical properties of haloalkane.
That, please.
अरे अच्छा ठीक है, नहीं आप एक काम कीजिएगा, इसको कॉपी करने की जरूरत नहीं है, आपकी नोटबुक में सब कुछ है फातिमा, yes or no?
I am only on the last one.
वो हम नहीं बोल रहे हैं. अरे देखिए सी वेट सकते, आप ढूंढ के अपने कॉपी में लिखेगा, ज्यादा बेहतर नहीं होगा?
Just last.
लिख लीजिए आप, लेकिन हम एक बात बोल रहे हैं आपसे, लीजिए आप लिख लीजिए, ठीक है, लेकिन हम एक बात कर रहे हैं कि अगर आप ढूंढ के अपने कॉपी में से लिखिएगा.
लिखना हो
Done?
गया?
हाँ लिखना हो गया. हम उसकी वजह से नहीं बोल रहे थे कि मेरे पास टाइम कम है, हम इस वजह से आपको नहीं दिखा रहे थे ताकि आप ढूंढ के अपने नोटबुक में से खुद से लिखती तो आपको ज्यादा याद रहता है ना, समझे जी। राइट हियर फिजिकल प्रॉपर्टीज ऑफ haloalkane halogen. देखिए, if you no I am telling this, I don't know how many times I have to tell this, but again a reminder is good, right? All of you must have seen that in examination, when you know some answer, then you don't remember the words, you remember the notebook or wherever you have learned that answer from. If it is a book, then you remember that particular page, particular section, particular paragraph of a book. Okay, so whenever you are going to write answer, it is good if you have a complete visual picture of your notebook. If you know each and every page of your notebook, for example, your notebook should be something like that. If I open up one page of the notebook and I tell that you have written this particular topic, then you can say that, okay, fine, the next topic will be this one. Then if you turn the page, you will have that topic. If you turn the page, you will have that topic. At least by topic's name, you should remember everything in your notebook. And then only you can answer very perfectly. And I mean, it will not be time consuming in the, like when you're writing the answers, if you know all of these things, okay? इसलिए हम चाहते हैं कि आप लोग ज्यादा से ज्यादा नोटबुक को अपने देखते रहे कम से कम. एटलीस्ट न्यूज़पेपर रीडिंग शुड बी डन, राइट? फिजिकल प्रॉपर्टीज. What has happened to this? Physical properties of haloalkane and haloarene. Right here, first point. On haloalkane have higher boiling point than parent hydrocarbon. Due to greater polarity and higher molecular mass. Okay, that means if you have halogen, it is going to have higher melting point or boiling point rather than any alkene. This is the parent alkene and this is my halogen. Okay, so write next. For a given halogen atom, the boiling point is directly proportional to number of carbon atoms. Now what we are doing, we are not changing any of the halogen atoms. So if I'm starting with fluorine, then I'm going to have fluorine only, right? For example, CH2X. I'm not going to change the halogen atom, okay? I have CH3X. It will have lower boiling point than 2 carbon atoms and then X. Then if we have 3 carbon atoms and X, it is going to have higher boiling point. If you have 4 carbon atoms and X, it is going to have higher boiling point. If I have 5 carbon atoms and then X, then it is going to have higher boiling point. So if we have, for example, this can be an example of CH3F. It will have lower boiling point than this one. Okay, now write next. For a given alkyl group, the boiling point is directly proportional to the molar mass, molecular mass or molar mass. Okay, so if I have 2 carbon atoms in fluorine, and if I am having 2 carbon atoms in chlorine, 2 carbon atoms in bromine, 2 carbon atoms in iodine, then iodine has the highest molar mass, that is why it will be higher, and then this will be the order for a particular alkyl group. So see, the alkyl group is same, we are just changing the halogen atom. So in what is changing in halogen atom, the molar mass is changing in halogen atom, that is why this will be the case. Now you write next. boiling point is inversely proportional to branching. And that is why if I have, let us suppose 4 carbon atoms, 1, 2, 3, 4 carbon atom, and I have a Br group. And if I just have 4 carbon atoms in the Br, and now we can see that we have increased the branching. This was linear, now it is a bit branched. And I can more increase the branching like this. Right, I have now all of these having how many carbon atoms? 1, 2, 3, 4 carbon atoms. This is also having 1, 2, 3, 4 carbon atoms. This is also having 1, 2, 3, and 4 carbon atoms. Now what is happening? If I increase the branching, the boiling point is going to decrease. Why it is decreasing? See here. If I look at the polarity here, we have delta negative here, and the delta positive will be here. The last delta positive will be here. So you have a polarity like this, and you should remember from your physics class that dipole moment mu net, it is equal to the charge into distance. Now, if this distance between the positive and negative end is a bit large, that means it is going to have a higher polarity. Here the polarity is decreasing, right? And here the polarity is decreasing even further. And that is why what is happening, when I increase the branching, then it is going to be, then the boiling point is going to decrease. Right, this point, let me know when you're done. Let me know when you're done, guys. Done? Okay. Write this question. Okay. So first thing is that you should know how to write the molecule structure. Bromomethane. So we have CH3Br. Bromoform. Bromoform means we will have 3 bromine groups. So you'll have CH, Br3. Then chloromethane, it is going to be CH3Cl. Then we have dibromomethane, it is going to be CH2Br2. The first criteria that you have to see here is the number of carbon bonds, and first criteria is going to be your molar mass. Okay, your molar mass. So we can see that this particular CHBr3 bromoform should have the highest molar mass, right? So I will write here A, B, C, and D. As you can see, what is happening? The carbon number is same, na? The carbon number same is, so what is going to happen? It is only differing in the molar mass. So B has the highest molar mass, that is why it will be having the highest it will be having the highest boiling point. Next is D, right? And then we have A. And at last we have C. This is happening because of what? This is happening because of the molar masses. Because you can see only one carbon atom, one carbon atom, one carbon atom, one carbon atom, and one carbon atom, right? So what we have seen for a given alkyl group, that means the alkyl group is methyl, right? All of them are methyl. This CS1 methyl, this is also methyl, this is also methyl, and this is also methyl. So if you have the same alkyl group, then it is going to depend on the molecular mass. Write this down. Let me know when you're done. Done, guys? Please tell me.
Done, sir.
Done. Now let's look at the next one. 1 chloropropane, 1, 2, 3 carbon atoms, and the first carbon atom will be having chlorine. Isopropyl, 1, 2, 3 carbon atom, and then this second carbon atom is going to have chlorine. 1 chlorobutane, 1, 2, 3, 4 carbon atoms, and then you will have chlorine. As you can see, the chlorine is same here. So that means what we are going to do, we are going to see first of all the number of carbon atoms. See, this carbon atom is more, right? A, B, and C. For all of these cases, you have to see first of all the molar mass. You can see the molar mass here. The C is having the highest molar mass, right? And between A and B, both are having the same number of carbon atoms and the same number of fluorine groups also. Now, what we can see that they are differing in branching. So, which is more branch? B is more branch. That means it will be having lesser boiling point. So, after C, we'll have A, and then we'll have B. The C is due to mass, and between this branching has B. This is due to branching. Write this down. Let me know when you're done. Please revise everything that has been taught till now. We'll have a test on